Alright guys, welcome back to this ASMR, which we'll be using this book that I've been having since I was little. Earth Science. And we're going to talk about the first chapter. I think I put a bookmark right here. So we're going to be doing, or I will be reading section 1, which talks about different things that are covered within the book, which we have geology, oceanography, meteorology, astronomy, and we have ecology, geochemistry, environmental science, geography, and cartography. And we're just going to go over that. Section 2 will cover the scientific method. But let's go with the first section. I will be using a stick just to guide me through as I read. So, these are the branches of Earth science. Planet Earth. How can anyone study something as large and complicated as our planet? One way is to divide the study of Earth into pieces, which are the pieces that I just showed you guys. It's easier to study something large and complicated if you break it down into smaller, simpler things. Scientists divide the study of the physical planet Earth into 3 general categories. Geology, which is everything with the earth, land. Oceanography, which would cover it, just ocean and water. And meteorology, which has to do with things around that happen on Earth, like a tornado. Basically, with the climate. Now, astronomy is the study of all physical things beyond planet Earth. Let's take a look at each of these 4 sciences and at some of the people and some of the people who work within them. Then we'll look at a few other areas of science that relate to these 4. So we have geology, the science of rocks. Geology is a study of solid earth. Anything and everything that has to do with the solid earth is part of geology. Most geologists specialize in a particular aspect of the earth. Would you like to put on an insulated suit and walk to the edge of a 1000 Celsius pool? pool of lava? If so, you could be a volcanologist, a geologist who studies volcanoes. Are earthquakes more to your liking? Then you could be a seismologist, a geologist who studies earthquakes. Now I know a lot of you guys probably don't or are not into earthquakes or volcanoes. Most people are afraid of them. How about digging up dinosaurs? You could be a paleontologist, a geologist who studies fossils. These are only a few of the careers you could have as a geologist. Some geologists become highly specialized. For instance, geologist Robert Frank at the Florida Institute of Technology explores the subsurface of the earth by scuba diving in underwater caves in Florida and the Bahamas. Frank says Bahamians call caves in the ocean floor blue holes. This describes them well. From the surface, they are usually dark blue, surrounded by bright white sand. And we can see a picture on the left which talks about the description of what Frank is talking about. Right here it says, from the surface, they usually dark blue. Underwater caves often contain evidence that sea level was once much lower than it is now. They contain stalagmites. I'm not sure. These formations develop from minerals in dripping water in air-filled caves. So, these right here are caused by the minerals, which describes here the formation from minerals in dripping water in air-filled caves. So, as we can see, it could be something that most of us would like to experience, or maybe not. Alright, let's continue. Alright, let's continue to oceanography, which is just water everywhere. Oceanography, which is the study of the ocean, is often divided into 4 areas: physical oceanography, biological oceanography, geological oceanography, and chemical oceanography. So the physical oceanographers is the study of things like waves and ocean currents. Biological oceanographers is basically plants and animals that live in the ocean. And geological oceanographers is basically a study of the ocean floor. As we can see, geology has to do with science of rocks, everything that includes rocks, which are basically the earth. And we know that at the bottom of the ocean, obviously, we have a floor, which are rocks, which is the study of geological oceanographers. And then lastly, we have chemical oceanographers, which is a study of natural chemicals and chemicals from pollution in the ocean. So basically that is oceanography for you guys. Now we're gonna skip this part and we're just going to flip the page and go to meteorology. So you might think that meteorology is a study of meteors. Not a bad guess, but not quite right. Meteors are the flashes of light seen when objects fall from space into our atmosphere. Meteorology, however, is the study of the entire atmosphere. When you ask, is it going to rain today? You are asking a meteorological question. One of the most common careers in meteorology is weather forecasting. Sometimes knowing what the weather is going to be like makes your lives more comfortable. And occasionally our lives depend on these forecasts, which in my opinion can be a really important career. Because as we know, if we live in an area that has a lot of, for example, snow or ice, knowing how it is going to be in the morning or what temperature, or to know at what temperature it will drop, you could prepare yourself for that exact thing better than just going out and not having a clue of what could happen. Hurricanes is one. As we can see here, we have hurricanes happening around the Gulf of Mexico. Meteorologists began tracking Hurricane Andrew on Monday, August 17. By the following Sunday morning, most South Floridians had left the coast because the National Hurricane Center had warned them that Andrew was headed their way. Hurricane Andrew hit southern Florida early on Monday morning, August 24. The hurricane caused a lot of damage, but it killed very few people thanks to meteorologists' warnings. That's why, like I said, it's a important career. So most of us know exactly what to prepare for. And as you guys see, it could save a lot of people's lives. And then we have tornadoes, which is just this. So another dangerous weather element is tornadoes. An average of 780 tornadoes touch down each year in the United States. What do you think about a meteorologist who chases tornadoes as a career? Howard Bluestein does just that. Bluestein predicts where tornadoes are likely to form and then drives to within a couple of kilometers of the site to gather data, as shown in figure 3 right here. By gathering data this way, scientists like Bluestein hope to understand tornadoes better. The better they understand them, the better they can predict how these violent storms will behave. So tornadoes are one of the dangerous, and they usually happen around like the mid of US or south of the United States. But it's something to really consider. And we have astronomy, which has to do with everything in space. This is our solar system right here. Now, How do you study things that are far away in space? That's a question that astronomers can answer. Astronomy is the study of all physical things beyond Earth. Astronomers study stars, asteroids, planets, and everything else in space. Because most things in space are too far away to sense directly, astronomers depend on technology to help them study objects in space. Astronomers use a variety of instruments. Optical telescopes have been used for hundreds of years. Galileo. Astronomers still use optical telescopes to look into space, but they also use other types of telescopes. For example, the radio telescope shown in figure 4, which is these right here. So these radio telescopes allow astronomers to study objects that are too far away to be seen using optical telescopes, or that do not give off visible light. Astronomers spend much of their time studying stars. Astronomers estimate that there are 100 billion stars in the sky. That's a lot of stars. Try the math break at right. To get an idea of how many stars there are. The most familiar star in the universe is the sun, because it's the biggest and it pulls gravity from all of us. So, which is the closest star to Earth? Astronomers have studied the sun more than any other star. Astronomers have also studied planets that are close to Earth. And figure 5 shows all the planets that there are. Illustrates the sun right here. Then we have the Earth, and the moon, and some nearby planets. Can you name these planets? So we have Earth right here. We have Jupiter, Saturn, Mars, Venus, and Mercury. Now, we're going to talk about the special branches of Earth science. In addition to the main branches of Earth science, there are branches that depend more heavily on other areas of science. Earth scientists often find themselves in careers that rely on life science, chemistry, physics, and many other areas of science. Let's take a look at some Earth science careers with strong ties to other sciences. So we have ecology. It is difficult to understand the behavior of certain organisms without studying the relationships between these organisms and their surroundings. Ecologists study ecosystems like the one in figure 6. So basically everything from water, plants, the ecosystem is a community of organisms in their non-living environment. The principles of ecology are usually in many related fields, such as wildlife management, agriculture, forestry, and conservation. The science of ecology requires people trained in many disciplines, such as biology, geology, chemistry, climatology, mathematics, and computer technology. Now we have geochemistry. As the name implies, geochemistry combines the study of geology and chemistry. geochemists, like the one in figure 7, specialize in chemistry of rocks, minerals, and soil. They study the chemistry of these materials to determine their economic value, interpret what the environment was like when they formed, and learned what has happened to them since they first formed. So we can see right here, geochemist taking rock samples from the field so she can perform chemical analysis of them in her lab. And then we have environmental science. So basically everything with the environment. Humans have recently begun to examine their relationship with their surroundings or environment more closely. The study of how humans interact within the environment is called environmental science, as shown in figure 8. One common task of environmental scientists is trying to find out whether humans are damaging the environment. Pollution of the air, the water, and land can harm natural resources such as wildlife, drinking water, and soil. Environmental science, which relies on life science, chemistry, physics, and geology, is helping us to preserve Earth's resources and use them more wisely. And lastly, we have geography and cartography. So, geographers who are educated in geology, life science, and physics study the surface features of Earth. Cartographers make maps of those features. Have you ever wondered why our cities are located where they are? Often, the location of the city is determined by geography. Many cities, such as the one in figure 9, which is St. Louis, they were built near rivers, lakes, or oceans because boats were used for transporting people and items for trade. Rivers and lakes also provide communities with plenty of water for drinking and for raising crops and animals. We make maps to record the geography of our world. Maps help us keep track of natural resources and navigate the surface of the earth. So, that is, this talks about scientific method. So, we are done for this video. Just helping you guys relax by doing some reading. So if you guys like this type of video, then give it a like, and if most people like it, I'll probably do another similar one like this. Maybe the next one will do the scientific method in earth science, which will talk about other different things, hypotheses, observations, and all that. So, thank you guys for watching, and I'll see you guys on the next one.